Hello, abstract algebra students. This begins the third lecture in chapter 1, entitled Semigroups of Numbers. So, I'm going to start by reviewing some definitions, but in the interest of time, I'm going to flash them in PowerPoint rather than try to retype them all. So, we have our old definitions that we have seen already. They suppose S is a set and star is an operation. And over the past two lectures, we defined four properties: the commutative property, the associative property, the well-defined property, and the closure property. Remember, the operations are commutative, associative, and well-defined on sets, but sets are closed under operations. And the definitions here are just the same definitions that I've shown in the first two lectures. I'm not going to rehash them now. Now, for a new definition, we want to look at algebraic structures that have all four of these properties. And we want a special name for those structures. So suppose that both S is a set and star is an operation. S is a semigroup under star means the associative, well-defined, and closure properties hold. Or in the bullseye, you see orange, yellow, and green. If in addition to associative, well-defined, and closure, you also have the commutative property, then you say S is an abelian semigroup under star when all four of these properties hold. Now, a semigroup is sort of the minimal amount of properties that we need, associative, well-defined, and closure, in order to analyze an operation. In abstract algebra, the adjective abelian is added on to the name of any structure where the operation is commutative. Abelian is named after the mathematician from the 1800s, the early 19th century, Niels Henrik Abel, who founded and discovered a lot of abstract algebra initially. Structures that are commutative, where the operation is commutative, often get the adjective of abelian. So if we have a situation where we have the associative, well-defined, and closed property, but not the commutative property, then we would say we had a non-abelian semigroup. Okay. Generally, when we are analyzing operations, we can't assume any property about an operation unless we have either proven it or it is given to us. Now, let us look. We have seen some familiar examples of semigroups already. Under addition, the sets Z, Q, R, Z plus Q plus R plus, Z non-negative, Q non-negative, and R non-negative are all abelian semigroups under addition. If you look at the bullseyes I flashed, they all had orange, yellow, and green, as well as red. Finally, all 12 of the familiar sets are abelian semigroups under multiplication. Notice in the multiplication bullseye, all four colors were filled in: red, orange, yellow, and green for all 12 of the sets. Now, under addition, Z star, Q star, and R star, the non-zeros are not semigroups at all because the closure property does not hold. 3 is a non-zero integer, -3 is a non-zero integer, but the sum 3 plus -3 is not a non-zero integer. So these are our familiar examples of semigroups. And over the course of the next few lectures, we are going to find non-familiar or less familiar examples of semigroups. We're going to start by looking at new algebraic structures. And remember, in an algebraic structure, you need a set, you need a notion of equality, and you need an operation. In this lecture, we will look at the following structure. Our set will just be the set of real numbers. That's familiar. Our concept of equality will be the familiar concept of exact equality. 1/2 does equal 0.5. 1/3 does not equal 0.33. Pi does not equal 3.14. Equality has to be exact. However, we will look at a couple of unfamiliar operations. One of them is double addition, which is just A star B equals 2 times the quantity A plus B. So for example, 3 star 4 would equal 2 times 7 or 14. The other is double multiplication. A star B equals 2 times the quantity AB. For double multiplication, 3 star 4 would be 24, which is 2 times 3 times 4. And our goal in this lecture is to investigate and either prove or disprove each of these 4 properties for each of these 2 algebraic structures. That is what we will now do. More to follow.